So now let's continue our work with graphing quadratic functions in standard form. And in this equation, we have f of x equals negative 3x squared minus 3x plus 6. So this is the first time that we've had an example where our a is negative. Did you notice? So a is negative 3, b is negative 3, and c is 6. So since our a is a negative number, that means the parabola is going to open downward, and our vertex is going to be the maximum point. Okay, so let's find the vertex. Using the vertex formula, x equals the opposite of b over 2a. So that's the opposite of negative 3. That makes it a positive 3 over 2 times a, which is negative 3. And so here we have a negative fraction with a negative 3/6, which reduces to a negative 1/2. So we've got a vertex in which our x-coordinate is a fraction, and we're going to find the y-coordinate by substituting the negative 1/2 into the original equation. Now I went ahead and did that in the calculator. So let me show you that work. Okay. I used my stow key and I stored negative 1/2 into x and then typed in our function negative 3x squared minus 3x plus 6. And so that gave me 6.75, which I turned back into a fraction, 27/4. So our vertex is the order paired negative 1/2 for x and 27/4, which is 6 3/4, as you saw, 6.75, as our y-coordinate. So then our axis of symmetry, which is going to go through that vertex, it's going to be the vertical line that goes through that order pair negative 1/2, 27/4. So we're going to write the axis as x equals negative 1/2. Again, a vertical line is an equation that you're going to give us for the axis of symmetry and not a single number, and so x equals negative 1/2. So to find the x-intercepts, we're going to set y to 0 and take our function equation. And so we're going to set negative 3x squared minus 3x plus 6 equal to 0 and solve for x. And I notice in this equation that there's a GCF, isn't there? There is a negative 3, and I'm looking at the fact that this leading coefficient is negative, and it would be easier if it wasn't negative. So we're going to go ahead and divide both sides by the GCF, which happens to be negative 3. And that's going to give us x squared plus x. 6 divided by negative 3 is a negative 2. And 0 divided by negative 3 is 0. So now we have a quadratic equation that factors x plus 2, x minus 1 equals 0. And we go ahead and set those two factors equal to 0 to solve for x. And we get that x equals negative 2 or x equals 1. So our order pairs are negative 2, 0 and 1, 0 for our x-intercept. For the y-intercept, we will set x to 0. And so we will get f of 0, which is negative 3 times 0 squared minus 3 times 0 plus 6, or 0, 6. And then we're going to evaluate f of negative 1. So now we have x equals to negative 1. F of negative 1, which is negative 3 times 1 squared minus 3 times negative 1 plus 6, which is negative 3 plus 3 plus 6, or negative 1 comma 6. So let's graph this now. Our vertex is negative 1/2, 27/4. So that was 6 3/4, so about there. And we have, of course, the axis of symmetry that's going to go through that vertex. And then we have the two intercepts at negative 2, 0 and at 1, 0. And we have the y-intercept at 0, 6. And then its mirror at negative 1, 6. And we had expected a downward parabola, and that's what we've got, with the vertex as the maximum point. And if we want to review our domain and range for this parabola, domain is all real numbers. And the range this time, notice that our vertex is our highest point. So that y value is the highest that y will be. And that was the 27/4. So notice how I'm going to put it on the right-hand side of our interval notation. And then notice how our arrows point down. So that means that our range has all these negative numbers down here, right? So y is any real number that's less than or equal to 27/4.